Jai Hind to all. My name is Vaishali Deshwal and currently I am working as an assistant professor at Akgec. So today's session is about blockchain architecture design. The code for this subject is KCS 714. And as we have discussed in the last lecture, we have discussed the several applications of blockchain in different areas. So today's session is about some other roles of blockchain in different sectors of government. For example, in PDS and in other food grain distribution systems, then blockchain cryptography and privacy and security on blockchain. So first is, what is blockchain? What is PDS? Public distribution system. So it's a Indian food security system which is established under Ministry of Consumer Affairs, Food and Public Distribution, and it evolved as a management of scarcity of food grain through the distribution of food grain at affordable prices. This system is operated under the joint responsibilities of central government and state government. So they have different roles in distributing the food grain. So the central government through FCI is an organization, stands for Food Corporation of India, and it has assumed the responsibility for procurement and storage and transportation and the bulk allocation of food grain to the state government. So this concept, PDS system, it was introduced in World War II as the wartime rationing measure to avoid the scarcity of the food. So before 1960s, distribution through this system, this PDS system, it was generally dependent on the imports of food grains. And one of the important feature of the system is the general lack of the accountability through the entire supply chain, and leaving the leakages that occur at the different points. So it needs a technology like blockchain, so which can be helpful in managing the supply chain effectively using DLT, that is distributed ledger technology. In case of the storage or when it comes to the storage of the data, so blockchain can play a very indispensable role. So entire supply chain starting from the procurement till disbursement can be a part of blockchain. So now we see the working of PDS system, that how it works and what are the different kind of the measures or the role of the state and the central government. So the central and the state government, they share responsibilities in order to provide food grains to the identified beneficiaries. Not all, some beneficiaries or some people are identified as beneficiaries, and to those food grains are provided under this system. In central and state government, they has their own role in implementing these type of the systems. So the center, it procures food grain from the farmers at MSP. MSP is the minimum support prices, and then it sells to the states at central issue prices. It is responsible for transporting the grains to godowns in each state. And now this is a point where the functioning of the state starts. So states bear the responsibility of transporting food grains from these godowns to each fair shops, or what we call as ration shops, where the beneficiary buys food grains at the lower central issue price, and many states, they can also subsidize these prices as fixed by central government. So further, the state government can also subsidize the price of food grain before selling it to the particular person or the beneficiaries. So this diagram, it explains the working or the role of the central and state government in implementing PDS system. So first end point is the farmer. Farmer has the crops, and the farmer sell crops to center. At center, we talk about FCI, that is Food Corporation of India. Then central government procure the food grain from farmer and allocate the food grain to state government at the central issue price, which are decided by the central government. Then the central government distribute the food grain to the FPS, that is the fair price shops, or you can say ration shops, And further, from here the beneficiary get the food at the central issue price, but these can also be changed depending on the central state government. Now, how we can implement blockchain in this system, or how it can ease the functioning of PDS system. So the use of blockchain, it can remove delay in payments. That is one of the advantage by implementing blockchain in this system. So it helps to remove the delay in payment to the farmers based on the procurement done by the miller. Now the miller is responsible for the collection or the stock initially, unless the transaction is approved by the farmer. So the miller cannot register the quantity collected. So somehow this transaction is non repudiation. And now the calculation, the payment, they must happen based on the initial data. So there is a need to store the data, initial data, and the data provenance. Provenance means whatever the data you are recorded or the history of data, it can be sealed using the several features, secure features of the blockchain. And decentralized distributed ledgers makes all the stakeholders refer to their local copy of the ledger. Means whatever the data which are related to the different stakeholders, we can store that data on this ledger, decentralized distributed ledger. And we have already discussed that what are some of the basic features of blockchain. For example, here we are talking about the distributed ledger, and that too as decentralized. Now there are certain activities which are involved in this particular system. For example, the payment to farmers, it can be done without waiting for the miller. And since the procurement season is defined for each commodity, the payment can start immediately without waiting for the directors to complete their process. So if we are implementing the blockchain in this system, the delay can be minimized to the maximum extent. And this makes each transactions as a non-time critical. Since the farmers, they only interact with the government identified millers, so that needs not to be a part of a public chain wherein the transporter is participating in the network. Okay, so this is one of the applications we talk about while we are discussing the role of blockchain in the different systems or the sectors of the government. So this is the POC application, stands for proof of concept application. So this proof of concept application, it's a Python web application. It's a Python web application and it's for the PDS system. So it interacts with the blockchain node and RDBMS. RDBMS is a relational database management system. So it interacts with these two. Now this application for the PDS is developed as a Python web application with the 3 stakeholders, and these stakeholders are, first is the miller, then farmer, and then the admin user, which is who is handling all these things. Now the application, this POC application, it interacts with the blockchain node and to the RDBMS and is developed in the Docker container. Okay. So such kind of the applications, they are prepared to make ease or to cover the procurement processes of the PDS system. So the main functions, this slide talks about the main functions or the role of this application in PDS. So it covers the procurement process of the PDS and it involves the miller registration. So it involves miller registration with the government and the farmer registration with the miller. So there is a module named the registration modules, and it writes the registration details to the blockchain as well as to the database, as we have already discussed that in this we are having two things. So this particular application, it will interact with the RDBMS also and the blockchain also. Next is the another module, that is the data updating module. So what it does, it actually read the existing data from the blockchain and write back the updated details. Then the other module is super user module. So it provides option to read and compare the data from both the database and the blockchain which helps to identify any data updation anomalies. So these are certain modules involved in the POC application. You need to know about these applications while we are implementing, and how they are helpful in making the functioning of such systems quite flexible. Next is the role of blockchain in social welfare systems. There are many social welfare systems running by the government. So how we can implement the blockchain in all those systems? So here we are discussing few of them. Rest you can just visualize yourself or study yourself. Government and its several welfare schemes get benefited by adopting the blockchain technology, or you can refer several initiatives, such initiatives taken by the different government of the different countries. So the government in the several welfare schemes get benefit by implementing the blockchain technology. It can improve its delivery service, which helps to remove the middlemen and prevent the tax fraud cases. Now, most of the government functions in the blockchain technology, they are essentially the same. And the government launches welfare schemes that are considered as a network involving the several stakeholders. Similarly, the blockchain maintains a distributed ledger. So here, it helps to maintain a distributed ledger. Next is the blockchain technology is increasingly used in the humanitarian responses, and whenever this terminology comes, we also these terminologies, they are quite related to the UN, that is the United Nations. So such type of technologies, they are also helping in implementing the humanitarian responses around the world, including the UN also. Next topic is the cryptocurrency. We all know what is cryptocurrency, what is asymmetric cryptocurrency, what is the symmetric cryptocurrency. We need to know the cryptocurrency in blockchain. So it's a method of securing data from the unauthorized access, and we will see how the role of the several keys in the cryptocurrency. So it's a method of securing data, and in blockchain the cryptocurrency is used to secure the transactions taking place between two nodes in the blockchain networks. So in blockchain there are two concepts. One is the cryptography and the other one is the hashing. You may heard about hash values. So cryptography is used to encrypt the data. So there are several terminologies, the role of the keys, private key and the public key, and encryption and the decryption, encryption at the end of the sender, and decryption at the end of the receiver. So it is used to encrypt the message in P2P network, peer-to-peer network, and while the hashing is used to secure the blockchain information and the link the block in the blockchain. Now it primarily give importance on ensuring the security of the participants' transactions and safeguard against the double spending. Cryptography also ensures that only the individuals for whom the transaction is intended can obtain the details and read and process the transactions. And it also helps in securing the different transactions on the blockchain network. Now we'll see some of the roles or the functions of cryptography in blockchain. So blockchain technology is developed with a range of different cryptography concepts, and the development of the cryptography technology promotes restrictions for the further development of the blockchain. So first point is about that in blockchain, cryptography is mainly used to protect user privacy and the transaction information because of its some secure features, and by protecting all these things, it ensures this data consistency. Second is the core technologies of cryptography. It include the symmetric encryption and asymmetric encryption. So in symmetric we are using the same key for the encryption and the decryption, and in asymmetric we are using the different keys. Now, asymmetric cryptography, it also uses digital signature. So it's a different concept, digital signature, and these are mainly used for the verification purposes. Every transaction recorded to the block is signed by the sender by the digital signatures and ensures that the data is not corrupted. Now, what is cryptography? So, cryptography is a technique or a set of protocol that secure the information from any third party during a process of communication. And there are certain terminologies which are related to cryptography. First is encryption, then key, decryption, and cipher. So, first is encryption. Let's understand these terminologies. So, encryption is the conversion of the normal text. Okay. So, conversion of the normal text to a random sequence of the bits. So, this is what we call as the encryption, and this is very much important for coding a particular message into a secure message. Then second is the key. Some amount of information is required to get the information of the cryptographic algorithm, and with the help of the key, the message can be decrypted. Decryption is just the inverse process of the encryption and the conversion of the random sequence of the bits to the plain text. And what is cipher? Cipher is a mathematical function, a cryptographic algorithm you can say, which is used to convert the plain text to the cipher text. Cipher text is the random sequence of the bits, which we talk about which we have talked in the encryption. So in encryption, we are just converting the normal text to the random sequence of the bits. The reverse we are doing in the decryption, and cipher is used to convert the plain text into the cipher text. Now there are two types of the cryptography. First is the symmetric key, and the second is the asymmetric key. In symmetric key, there are certain key points. First is the similar key, that it focuses on the similar key for encryption purpose and for the decryption purpose. Means while we are performing these two, it is using the same key. And the most importantly, the symmetric key encryption method is also applicable to secure the website connections, and it is also referred as a secret key cryptography. So the only problem in this is that the sender and the receiver, they exchange the keys in secure manner, and the popular symmetric key cryptography are the DES, that is data encryption system. So this is one of the example you can write under this encryption. You can write also AES or DES. So these types of the algorithm, these utilizes the key in the cipher to encrypt the data, and the data must be accessed. So this is the diagram to show symmetric cryptography. In this you can see for the encryption and the decryption purpose, we are using a secret key, and the key is same. So the same key is used for the encryption and for the decryption purpose. Now here the plain text is converted into the cipher text, and again the cipher text is converted into the plain text. So this is at the sender's position, this is at the sender position, and this is at the receiver's end. Okay. Now in the asymmetric also the same process is going on. Firstly the plain text will convert into the cipher, and then sequence of the bit will get converted into the plain text as similar to the symmetric key encryption. The only difference is the role of key. So here the key point is the different keys that for the encryption and decryption purpose. So encryption method, it uses the private and the public key methods here. This public key method, it helps completely unknown parties to share the information between them. For example, the email ID. Or the private key helps to decrypt the message, and it also helps in the verification of the digital signatures. So the mathematical relation, if we see, the mathematical relation between the keys is that the private key cannot be derived from the public key, but the public key can be derived from the private key. For example, ECC, that stands for the elliptic curve cryptography and digital signature standard. So these are two examples which you can write under this type of encryption. This is the diagram, and it is showing the asymmetric cryptography. So here At the sender end, the plain text is converted into the ciphertext, and then at the receiver end, the decryption is going on in order to convert the ciphertext into the plain text. Here we are using the different kind of the keys, public and the private key. For the public key is used for the encryption purpose, and the private key is used for the decryption purpose. Okay. So we'll see this topic also, cryptography hash function in blockchain. So what is this? So one of the most important use of the cryptography is the cryptographic hashing, or you can say hash. So what is hashing? It enables the immutability. Immutability means which cannot be changed, and it is one of the core feature of the blockchain, and hashing enables the mutability in blockchain. So the encryption in cryptographic hashing does not involve any use of the keys. This is the important thing. And when the transaction is verifying the hash algorithm, it adds the hash to the block, and a new unique hash is added to the block from the original transaction. And this is how the blocks, they are connected to each other. This is what we have already studied in the unit 1, that how the blockchain is formed, how the blockchain are attached, and what is the hash value. So hashing continue to combine and make the new hashes, but the original footprint is still accessible, and the combined hash is called the root hash. So the hash function helps in linking the blocks, and this is how the why we are saying the block chain. So with the help of the hash values, the connections of the blocks are possible to maintain the integrity of data inside the block, and any alteration in the block, it will lead to the break of the blockchain. So some commonly used hash function are SHA and message digest. So this is it for today. In the next session, we will discuss properties of the cryptographic hash, then what are the benefits, then use of cryptographic hash functions, and benefits of cryptography in blockchain, some limitations, and then the last topic is the privacy concerns and security aspects in the blockchain.